Hello guys, we will be starting with oxidation reduction chapter today. This chapter will not have many direct questions in competitive examinations, but this will be pivotal to understanding inorganic and organic reactions. All the reactions basically that we will be studying for inorganic and organic will have either oxidation or reduction in it. So it is better that we understand this concept of oxidation reduction at this moment to make our life easier while we go into the sea of inorganic and organic reactions. So first we will brush up the old concept that we had in class 9 and 10 on oxidation and reduction. What is oxidation? Oxidation is basically addition of O2. We already know that. So there is nothing much to discuss about it. On the other hand, reduction will be meaning removal of O2. If you see here, this hydrogen takes away this oxygen from copper oxide, to be very precise. So this copper, from this copper oxide, becomes free. So this copper loses oxygen that was attached to it. So it has been a removal of O2 by hydrogen. So that is why it has been termed as reduction. On the other hand, if you see, this hydrogen collects this or captures this oxygen from this copper oxide and becomes H2O. So on the other hand, if you see the oxidation point, you will see addition of O2 is an oxidation. So this H2 has been added with an oxygen to form H2O. So that was an oxidation. So this reaction, if you can analyze this reaction, H2 has converted to H2O, that is oxidation. CuO has been converted to Cu, that is reduction. So there has been oxidation, there has been reduction. Now we already know that addition of oxygen will be oxidation. So oxygen is an electronegative element. Addition of any other electronegative element will be also termed as an oxidation reaction. See, over here FeCl2 plus Cl2. So this FeCl2 takes another chlorine and forms FeCl3, that is ferrous chloride becomes ferric chloride. This is again oxidation because chlorine is an electronegative element. Chlorine is an electronegative element, correct? So that is the reason we will term is an oxidation. On the other hand, if we see for the reduction purpose, removal of any other electronegative element, any removal of oxygen was reduction, removal of any other electronegative element will be reduction. So here FeCl3, it has been passed by H2S, and this H2S will remove this chlorine from FeCl3 to form ferrous. So from ferric it will go to ferrous. So it basically loses one chlorine, and this H2S also breaks up. One chlorine adds to this hydrogen and forms HCl. So this FeCl3 to FeCl2 is a reduction. Let us point out these things. FeCl2 loses a chlorine to form chlorine. Let's write like this. That is. So it just releases one chlorine. So we can say that it is a reduction. Next, what happens? H2S. H2S gets devoid of hydrogen. This is oxidation. Why it is oxidation? We will just come to it in the next phase. And what is remaining now? This H2 gets